award. So, hi, my name is Eric Busboom. I am the founder and director of the San Diego Regional Data Library and the company Civic Knowledge that runs the data library. And we're going to talk to you a little bit about the software that is the background, or the backbone of running the library and providing data to civic and social organizations, governments, and nonprofits. We were running the library. One of the first problems we had was how to fund it, and that involves cost, and you have to figure out why is data expensive, because it is. And we realized a lot of the reason for that is because we do data projects like medieval cobblers made shoes, and this kind of ad hoc, no process, non-repeatable kind of environment. In order to get those costs down, we need to go to an industrial mode of production. And for us, that industrial mode of production involves these wonderful gentlemen. Points, we can figure out who all of them are, particularly that guy on the left there, or the bottom corner. Specialization, interchangeable parts, assembly lines, and multi-mode shipping containers, the reason you can get shoes from China for $20, are all components that we can apply to data to make that whole process less expensive, and by making it less expensive, get more social data to more organizations so they can make better decisions about their operations. Now, we've put all that stuff into some software we call Ambry. It's named after a container for holy oils, or I think British use it for pantries. And Ambry is a way of creating it's a process that allows people to specialize on specific parts. So the data wranglers can do their thing, and the data scientists can do their thing. They don't have to be the same person. This tends to drop your costs quite a bit. It also allows us to share components in various parts of the process, so that the stuff that data wranglers do, which now gets done over and over and over again, in California, working with the ACS, there's probably several hundred people who have all done exactly the same transformation on the American Community Survey. We allow that to be shared, and by doing so, reduce the costs. So with Ambry, we have a prejudice towards IPython notebook. You can do things like this. Pull in the library and get a data set by a well-defined name, structured name. We also have a lot of unique numbers that allow you to have the same name but different numbers. You can take those things. These return you an object that wraps a SQLite data file, all the data stored in SQLite, which means you can attach them together, and now you have a SQLite file you can do queries against. The system also gives you ways to do sorting and searching. You can find packages by specific keywords. Once you've found those packages, you see they've got semantic versions, so there's versions to every package. You can take those names, get them, and then plug them into a SQL query and ask for pandas back to get data frame. So this process, these 5 lines at the start of your IPython script, means some really important things. One is it means your IPython notebook is repeatable. You can ship it to somebody, they can run it, which you can normally do, except for the problem of how do you give them the data. When those data sets are large and complicated and sometimes encumbered by privacy and have passwords, this becomes a problem. Also becomes a problem when somebody updates the data set and didn't tell you about it. All that stuff is packed into Ambry, and it allows us to make data science within the social realm repeatable, which currently is not. This is a manifest file. It's one of the other ways that you can work with Ambry packages. We've got a bunch of, these are called partitions here. These are from 211. 211 is the folks you call when you've run out of money at the end of the month, you can't pay your bills, so you need food stamps, or you need a place to live, mental health services. They have a bunch of phone calls. We've collected those. We can make extracts of these things, take named tables within our database, which are, these get installed into a relational database. We can take those tables, export them to CSV files, and create entire structures of CSV files from SQL queries that people can work with without having to work with Python. So if you're working entirely in the CSV space because you're a journalist and you've got Excel, this allows you to do that. This is outputting to a SQLite database. It's local, but you can also send it to relational databases. You can send it to RDS, Amazon. It'll do geographic, so either Postgres or PostGIS. We're working on getting it work on BigQuery. So I'm sorry, not BigQuery, Redshift. So you can do Amazon massive data warehouses. The basic structure of Ambry is that it breaks data sets into partitions, and those partitions are joined by a bundle. The bundle is the thing that's got all the metadata. Has the schema, tells you what all the tables are. gives you all the names for everything. The partition actually holds the data. The partitions are really important because if you were working with the census is 250 gigabytes, you're not going to download that. If you're trying to work on the census on a coffee shop, you're certainly not going to download it. Partitions mean you can just download the part you want. Often within the census, those are very, very thin slices, much less than a state even. They tend to be in the 5 megabyte range rather than 250 gigabytes. All those bundles and partitions are created through a package that's largely run on Python and YAML. This is one of the jobs we may have, is creating these packages. These things are configured with CSV files, usually somewhere on the web, pulls them down, figures out the schema, changes the column name so they're sane, puts it into the schema, occasionally merges it with other stuff, and then loads it into the Ambry library. There's also quite a lot of documentation that goes in here so you can actually explain to people what that package is. Once you've installed these to the library, you can create lists of them. We'll get about 60 or 70. So there's quite a lot of them from the census. We get different versions of different files. Stuff from the BEA. We're working on converting almost all the health data within the state of California. There'll be a massive terabyte database of hundreds of data sets all related to health. And they'll be in a list like this, which you can synchronize down to your laptop. This is a little bit of information about the package. Like I said, they're all SQLite. You want to see what's inside of it, you fire up SQLite and you look at it. It's really SQLite's a wonderful environment. Once you've gotten those packages, you put them into a manifest. This is a manifest in TextMate rather than in IPython. The manifests not only allow you to specify the extraction, but you can also specify SQL queries that you would use, both materialized, they go to tables, or regular views. And those are things you can access from Pandas and IPython as well. What that manifest generates is not only a database, but also all the documentation for the database, including all the tables that created, all the views, complete documentation for all the bundles that go in it, all the way back to the original agency that produced the data. So some of these data sets, our crime data set is 12 constituent files. It goes back to about 4 levels. Figuring out where your data came from is hard unless you generate the chain of provenance like that. We use that primarily within the library with our students and interns and analysts. Do this through IPython. If you want to look at our IPython outputs at notebooks.sandiegodata.org. Got some really interesting stuff on star tests and California API scores. And in that environment, people work off the warehouse using the CSV files. This makes it a lot easier for people to focus specifically on doing pandas and not worrying about learning the rest of the Ambry structure. That all fits into a process that involves data wranglers who are Python programmers that work specifically with the bundles. System administrators, they write the VBAs, they write the manifests, they have SQL skill. And they're producing these databases, outputs, and other stuff that our data analysts can use. So these folks in the middle really aren't Python oriented, but the people on either side are. And the whole system allows them to focus on just that piece rather than to figure everything out. Teaching SQL to everybody that comes through our program is really hard, so we kind of prefer not to do that. This allows us to avoid that. I love SQL, but I don't have to teach it anymore. It's got a lot of other features. Boy, I'm already 3 minutes over. Sorry about that. I thought I was talking faster. It's got a lot of other stuff that I'll tell you about later if you're interested. One thing I do want to point out is that we will be using all this in a data analysis contest. We're working primarily with student teams, so I'd like some of you guys to be the mentors. And we're running a training program before that. We also need speakers for this. All the data will be coming out of Ambry. We've got 4 projects. I haven't announced them yet, but they're socially significant projects dealing with things that journalists might write about. So if you're interested in either talk to me and get a card, or you can sign up for our announcements at sandiegodata.org/contact. Thanks. Sure, go for it. Okay. It doesn't end in anybody's pocket. Yeah. Okay.
So Q&A afterwards, or?
questions after each
We'll
talk or at the
Yeah.
very end? What do you guys think? After each one?
Yeah.
You want to answer a few questions while he set up then? Yeah, sure. Actually, that's a good in-between period, in between setup.
Any questions?
I got a question. So who are you with else in fact clear on?
The nonprofit that does data analysis is the San Diego Regional Data Library. San Diego Data.org. What's that?
You mentioned affiliation with SDSU.
Yeah, we're working with SDSU on the contest. So a lot of the students go to SDSU, and some of my employees are SDSU students.
Is it open to students from other schools too?
Yes, we're going to be announcing that soon. We haven't nailed the contacts, but if you've got any, are you with a school? Are you with a school?
Well, I went to Cal State San Marcos. And I
Oh,
was
fabulous!
the
I'm
ACM
very eager.
president there, so I have a lot of contacts.
We'll chat with you. We're really interested in getting San Marcos folks. So, and we'll definitely we've got some folks at UCSD. So we got those three schools at least. But any others we're very interested in chatting with. Anything else? Thank you.
Is this on, is the library an open source or?
Oh yeah. Yeah, we're. I don't like to pick
It's on source code?
Oh yeah. If you go to if you look for I think it's SDRDL our abbreviation, but it is on all of Ambry is in open source, as well as all our bundles. So if you want to recreate the entire census, you can run that as long as you've got 4 days of time.
Right. Hello, everyone. I'm Peter. I'm not from the US actually, so I'm from Germany. I'm just for vacation here, but I'm going to talk about Code for America or Code for San Diego because I'm involved with them, but I'm going to talk about that later. So, yeah. Code for America, Code from San Diego has a specific mindset. We want to build together building a government by the people, for the people, and which works in the 21st century. So is everyone familiar with Code for America? Probably not, right? Yeah, okay. So if you want to check out Code for San Diego, it's codeforsandiego.org, or specifically Open San Diego, because they two merged right yesterday. So yeah, we have Code for San Diego and Open San Diego, and now it's going to be just one, Open San Diego. And so Code for San Diego is the local chapter or brigade, how they call it, for Code for America. And Code for America is a non-profit organization that tries to help government agencies and government civic organizations to adopt web technologies and to impose transparency onto them, so that government gets transparent enough and that the processes are more open for everyone. So yeah, so the primary goal is for us to help San Diego's government agencies to adopt web technologies, open web technologies, and to use open source specifically. And we want to assist in making sure San Diegans get the best citizen experience in all the nation. So that's the main goal. How are we going to do that? There are a few projects I'm going to go over. So the first one is the open data policy and the chief data officer that comes out of the data policy, and the new city website. And one project I was involved in is the infrastructure engagement sites, but I'm going to talk about it later. So the open data policy was approved by the City Council on July the 2nd. And Open San Diego, or Code for San Diego, helped drafting it. They were in the advisory group that helped to implement the open data policy. And out of the open data policy, there will be a chief data officer assigned. I don't know when, but the application process is already over. So hopefully we get one in October or so, and he will be overseeing, or he or she will be overseeing the implementation of the open data policy, so that all the data that is inside the government gets published openly, so everybody can use it, and so we can build projects, outlet, websites, or applications to use these open data. And the new city website, I don't know if anybody of you noticed it, but yesterday there was an announcement or like press conference from the mayor, Kevin Faulkner. No? Okay.
Yeah, out of co-merge, right?
Sorry?
Is that the one they did out of co-merge?
Yeah, right.
Yeah.
And there's a YouTube link. I'm gonna push these slides up, but there's a YouTube link. They made a Google Hangout to talk about this stuff. Yeah, to have something cool, right? Yeah, and one of our leads, Jeff Johnson, was there and talked about it a bit. Yeah, and there's a survey. If everyone is interested in applying for helping build the new website, you can apply via the survey, and it's going to be a much easier process than usually. So it's not the typical procurement that is out there, but it's much easier. So you only have to fill out the survey, and then you're up to getting maybe selected to help build the new website. And the one I was involved in is the infrastructure project. So we have made online tools for public input and transparency in the infrastructure project planning. We implemented it closely with the City Council Infrastructure Committee, and why I'm here, it's because it's built with Python. We use Django for that, so yeah. And this is one of it's the shareabout map, so that's the community input. It's we present it on a map, and everybody can vote and comment on it, so that the council gets a better overview of what the people, or you, everybody, think about the project that the community groups come up with. And this is the actual information side, which is built with Python, Django, and yeah, we have a huge map, and you can explore the project that the city will implement in the next couple of years. All right, so if you want to get involved, come to the regular meetups for Open San Diego, or come to a special event. So we have meeting the candidate right now, and I think in a few weeks there's the next meeting. You can help out implementing it. So as I said, the infrastructure side is with Python. So if you are interested in that, it's openly on GitHub, so everybody can take part in it, because everything we do is open source. So you can check it out, or you can talk to us. Or specifically, you can talk to these two guys. So we have Jeffrey Johnson on the left side. He's our brigade captain, and Benjamin Katz. Maybe a few of them know him. He's from Open San Diego. So yeah, and just one quick short. I'm actually from Germany, so sorry for my English, but yeah, I'm here on vacation, but I'm involved with Code for San Diego and have implemented stuff because I'm running the Code for Germany and Code for Münster in my local town. So that's why I'm all over it. And yeah, I'm from Germany, I'm a student, I'm a developer, and I love San Diego, that's why I'm here, and I love the progress. Yeah. All right, thanks.
So when are those meetups?
They're usually once a month. I don't know when exactly, because I usually don't go to the meetups. But you can check it out on opensandiego.org. Yeah. Yes.
Is it open source?
What?
Yeah, so that's on GitHub.
Yeah, it's on GitHub. So the website.
Yeah, it's everything open source. Yeah. I don't know about the new city website, but yeah, everything we do is open source here.
Jeff has anything to do about it, it will all be open source.
Yeah. Eric knows him, so. Okay, thanks.
And one other thing, is that specific to San Diego City or the region, or
It's with the region. Yeah.
to San Diego at all, by any chance?
Yeah, a bit. So Jeff lives in Oceanside, so we have the region covered.
You can draw. Go ahead and draw.
Yeah.
Did you get a race?
There it goes. Okay.
Yeah.
Okay.
Wow, we're good.
Hey,
That says keep this speed or something.
You know, this has always worked in the past. I don't think we will keep this configuration.
It just takes a minute to find, swap cycle back to the
There goes.
I thought it'd be awesome if the government had like all
Okay, so I can touch anything.
all the expenses going out, and anybody could audit it, figure out exactly where all the money goes. Well, he's working on it.
I
Yeah,
didn't.
Super America is looking.
I didn't know that you can draw
Okay.
the centers.
Okay. My name is Young, and oops, there it is. My name is Young, and I'm going to talk about Numba. So Numba. How do I get rid of this? I'm not going to. I've never had this problem before. So I'm going to talk about Numba, and so the motivation for Numba is that in Python we actually sacrifice quite a bit of computational speed. I mean, a lot of things Python is plenty fast enough, but if you're working in the area of scientific numerical computation, which is actually my background, I'm a scientist, you're often running into that kind of limit of computation speed coming from Python. So because of that, there are actually lots of different methods that people have come up with, lots of different projects that people have come up with for increasing the speed of certain parts of Python code. And I'm going to be talking about just one of them, which is Numba. And Numba does that through what's called the LLVM compiler infrastructure. So quickly, what is LLVM? The idea of LLVM is that you can start with several different languages in the front end as the input, and it has a front-end converter that converts everything pretty high upstream into what's called the LLVM intermediate representation. And the LLVM intermediate representation is just code. It just looks like kind of low-level code. And so the thing about that is that whether you start from C or Fortran or C++, everything gets converted to this intermediate representation, and then everything downstream of that, all the other tools for optimizing the code for your, to get the actual executable file is actually shared, regardless of what language you started from. So, and probably the best known kind of like family or best known kind of project that uses the LLVM is Clang or CLang, where it's a system where you start from either C, C++, or Objective-C. It gets converted to this LLVM intermediate representation, and the idea would be that everything else is optimized downstream, and you use the same libraries and tools here for optimizing the code for whatever platform you need. So if this thing works then for C, Objective-C, or C++, then the idea is, well, we should be able to do the same thing with Python. Why not do the same thing with Python? And so that's the idea of Numba, is to take it in through this entire kind of system of tools for compilers. And if you can create this intermediate representation well enough, then the idea would be, and the hope would be, that you would get the kind of computation speed you would get with C or C++. So then the installation. So I installed it on a Ubuntu 14.04, and what that involved was installing the liblvm library, and then a couple of different Python packages, LLVMPy, which is the Python bindings to the LLVM library, and then Numba. So I mean, it wasn't difficult to install. It wasn't a simple one-liner trivial installation. But the people behind Numba are also the people behind the Anaconda distribution, if people are aware of that, the Anaconda Python distribution. So perhaps maybe the easiest way of getting Numba to test it out is just get the Anaconda Python distribution, and I think Numba is just in there by default. So what I wanted to do was I wanted to test out kind of and compare the computation speed ups that I got from using Numba. And what I wanted to do in particular was use NumPy, and it's not really an algorithm. All I wanted to do was calculate the inner product of a vector, or the dot product of a vector. And one way I do it is using the vectorized NumPy operator and method. And the other one is through a for loop, where I take element by element and multiply them together to get the inner product. I wanted to do this because I know doing it this way, NumPy is very fast. You do your vectorized operations with NumPy, and things usually work pretty fast, not that much slower than C. If your algorithm somehow requires you to actually access the elements, the array elements one by one in a for loop, I know that's when really things kind of come to a grinding halt in my algorithm. So these are the kind of two extremes. I wanted to see what Numba can do with something that's already pretty fast up here when this vectorized operation, and then compare it with what I know I have a lot of problem with, is when I have to access these array elements one by one through a for loop. And how do I use Numba? Well, I import the JIT from Numba, and then this is it. I just say, I already have my Python functions written out, and I just have this one liner, JIT, that function, and it gives me a Numba function. JIT, the other function, gives me the Numba function. So, I mean, this is very, very nice. I don't know if anybody's familiar with Python, but to try and do this, trying to speed up things with Python using NumPy array, 3 or 4 steps, where you have to generate C code, and then compile it, and then read that in. And so, when I saw this, where I just take my existing code and I just put a one-liner there, and I'm supposed to get all this kind of speed improvement, I thought that was just absolutely fantastic. So, what was the result that I got from this particular test? Well, the first thing was in the vectorized NumPy array multiplication, where I'm using the vectorized operations and methods, there was essentially no difference when I put Numba in there. And that's kind of expected because in NumPy, you're doing these vectorized operations, you're not doing that much in Python, you're just pushing it down to C calls that through NumPy. So this is kind of what I would expect. It's almost no difference. Then I went and looked at it for element by element multiplication. And if I just do NumPy by itself, it is off the charts. Okay, so that's that for loop where I'm accessing element by element. And on this one, it was 1,000,000 elements. And it is just out of. So you're paying a very heavy price for going into for loops and accessing these NumPy elements one by one. And in fact, if for some reason I had to do it with that many elements, I think I would be probably better off converting all of them into lists from NumPy arrays and then doing the for loop. Because Python, pure Python itself, actually that bracket that you use to actually access each of the array elements is a very costly thing to do. So just something to keep in mind when you're writing this code. And then with Numba, so I take the exact same thing and I just put that JIT one-liner to it, and it just drops it way down here. So it was faster than NumPy. It was just blazing fast. I mean, more than 2 orders of magnitude. And then it was actually much faster than what I was able to. I did the same thing with Python, and I was much faster. It turns out that particular, I didn't know when I was doing this test, but that particular inner product algorithm is very biased toward Numba. So you shouldn't take away from this that by using Numba you're going to get an order of magnitude improvement from Python. In general, when I'm doing testing on other algorithms, that wasn't the case. But it's, you put in one line of code and then you get something that is actually, through a for loop, you get something that is comparable to NumPy vector operations and through what you would do with Python. Somewhat comparable. I mean, in this one, it blows everything away, but I wouldn't say, break up your NumPy vectorized code and start using for loops for everything. Okay? This is Numba uses LLVM. Well, I mean, Numba, the idea is that you use convert one function or a particular part of your Python code through LLVM to something that runs much faster. Why don't you do it through the whole language? You know, write a dialect of Python that takes the whole language through LLVM and ideally works faster. I don't know of a project that does that with Python itself, but anybody familiar with Julia? So Julia is a kind of newly developed language specifically aimed at scientific computation, and there that's what they do. The whole language goes through LLVM, creates the intermediate representation, and ideally they advertise on their site that you should get the same comparable speed as C or C++ code. That's the goal. What I got in my testing was that it was a bit slower than what I would get with direct NumPy multiplication and much slower than Numba. That's just what I see. So then the question is, should we just all switch to Numba? It's just a one-liner JIT statement. Should we just put that in every single function that we have and just run with Numba? The overall testing that I did was that the quick answer to this is at least not yet. What I see for that particular example of the vector inner product and every single example from the Numba website, you just get blazing improvements in speed. So then I thought, well, I use Python a bit. Why don't I go to the Python website, get some code from there, and see what happens? And the result of that was very different. The first thing I did was I just copied the Fibonacci and the prime number algorithms from the Python website, and then I just put that JIT one-liner on it. When that happened, the whole number just crashed. Then I just kind of fiddled with it, rewrote it, and then I got it to actually not crash, but I got it to actually run slower than Python, which was a shock. So that's not slower than Python or NumPy. That's slower than standard Python. So that, what they say on their website is, if Numba is not able to come up with its intermediate representation, it should just keep the Python and just run it through Python. So I thought the worst case scenario would be it would run at the same speed as Python, but I got things using Numba that actually ran slower than Python itself. And then fiddling around with it, I actually did get it to run much faster than Python. My feeling right now is I think it shows a lot of promise. I'm really excited about having this opportunity of using Numba and having very quickly and simply getting all the speed improvements in my code. But at least from my understanding of it, I'm not ready to use it for some of my critical applications yet. One of the things I do see is that if you go to the Numba site, they say their goal is to have integration with NumPy arrays. And that is what I see. With NumPy arrays, it does a pretty good job of speeding things up. But if you have normal Python lists in there, or if your code is mainly based on Python lists, it actually has a hard time with it. And so that was the kind of problem, because Python actually works better with lists than it does with NumPy arrays. Numba works much better with NumPy arrays. So that was the problem that I was having, where I saw everything just having these huge speed ups with all the examples from the NumPy website. Then when I went to the Python website, where they're kind of emphasizing using standard Python lists, because that's where Python works best, Numba just barfed on that code. So if you want to use it, I would say just be careful and do lots of tiny tests and lots of tests with it. Don't assume that you are, at least, at this particular version that I was testing, 13.4, that you're going to get that speed up is guaranteed. And then the last thing was, this is for kind of a real algorithm, calculating prime numbers. I just kind of wanted to, again, do a comparison. With Numba, 6 milliseconds. With Python, I was able to get it down to 2 and 4 milliseconds, doing the same calculation of finding the first 1,000 prime numbers. And again, those were somewhat faster than what I was able to get with Julia. So that's it.
So, I don't know a whole lot. I was going to say that it's really interesting to see that that LLVM is being used for this, because I know that Apple uses it for compiling their JavaScript engine to do the same thing, and I'm just really amazed that they were actually doing something. I was more of just a comment, but that's really impressive. It's amazing gains that you can get from that. I mean,
Yeah.
they're not always going to be spectacular, but it's always nice to get something, and it's an extra step. That's
Yeah,
really awesome.
and I should say that this code here that I had here, usually what you would specify here are the kind of the type input types and the types that you get out. But if you don't specify it, it infers what the types are. And in this particular case, it inferred it quite well. And whereas with Python, it's actually quite a bit more work. And so it's quite amazing that with just very little effort. Yeah.
Do you know where the adapter is?
Who has an adapter?
Yeah.
That's short.
Yeah.
Oh.
You.
So originally you had C, and it went into LLVM. Now
Yeah.
C is already fast. Does the LLVM pipeline conversion actually make it faster?
You know, I don't know. A lot of people, so that's the idea of Clang, is that it does C, C++, and Objective-C, and all give you the intermediate representation. When I haven't played around with Clang myself, but when I've read up on it, they don't advertise it as somehow being faster than GCC, but it has other advantages supposedly in, I can't even remember now, in terms of like debugging, tracking. I mean, I don't know that much about it, but I've certainly talked to a lot of people who are thinking about converting from GCC into Clang. So it's gotten a lot of notice and publicity. I don't think it necessarily is faster than, say, GCC.
It tends to give better warning messages and output.
Yeah. Okay. That was
It's just one.
Just one comment is that so usually speed usually comes at the cost of memory. So it's one of the general rules is that you can't optimize both memory and speed.
Yeah.
So so a memory usage thing would be good. And another comment would be that compilers are already converted to an intermediate form. GCC will always convert. So multipass compilers will usually do the intermediate themselves. So I'm wondering how JIT achieve this speed. Is it due to caching? So what does the JIT do?
Yeah, I'm not really sure exactly what's happening kind of under the hood. I mean, my understanding of LLVM is that, a lot of things do that, but come up with this intermediate step. But my understanding is that it does it far upstream, and then it shares a lot of the libraries and code for optimizing.
But there are tricks over there, because let's say for NumPy, in the backend it uses a math library, right? So if the math library is optimized for our later CPUs, maybe it works just as fast.
It just as fast with.
Yeah. So if you use like a math library optimized for your particular CPU, then it's an even comparison. If you take a library optimized for 386 and compare it to fully optimized Clang or some other implementation, obviously it's going to be slow.
Yeah, that might be the case. I think what I see in general on my system is that NumPy, Numba, and Python code can be made to run roughly about the same. In terms of being able to, and in general, a bit faster than Julia. In terms of being able to try and get the most out of each of those methods, yeah. You might be, and people who are more familiar with Julia may be able to tweak it in terms of, in a certain way to get better performance out of it. So I didn't spend that kind of time to see what's the absolute best performance I could get from each method, but just from my general level of knowledge, what I'm able to get, and very easily I'm able to get pretty fast, pretty good improvements with Numba in comparison to other methods. Yeah.
Just
just a comment. If you want to test Numba on existing code, you don't have to go through all of your code and wrap out functions you want to optimize the JIT. You can just decorate it.
Yeah, I do. JIT is a decorator. In a 5-minute talk, I didn't want to explain decorator, so I wrote it like that. But yeah, you just put a decorator statement in front of your function, and and all your code stays the same. Any other questions?
We're all set?
Yeah.
All right, cool. So in Python, I've heard a lot of people say things like, we don't really need static typing because if you do your unit tests right, then it shouldn't be necessary. Now, I kind of disagree with that idea because I look at static typing as basically a way of having the computer automatically write like thousands of unit tests for you, and they're bug-free, pretty much guaranteed. So, you know, it's going to help you somehow. Even if like maybe you're really good at not making mistakes, eventually you're going to make a mistake, and it's probably going to save you a lot of time. So I actually made a mistake that was a pretty nasty mistake that luckily I was working on a development system at the time, but I'll show you, like, this is kind of a sketch of the bug that I made at one point. So if you look at this, the idea is that I'm say running like some big task and I want to be able to run multiple processes on it. So I have a function here, it's called spawn worker, and this is just a dummy function, but in here, say I'm doing like some, I'm like say forking a new process and then doing some long calculation in there. So I just make it print something, and then I'm storing the PID so that I can reference that in some global data structure. Now, ignore the fact that I don't like these global data structures, but this is just kind of a mock-up. So then there's this function called spawn workers where we're going to pass in a number of how many workers we want, and it's just going to loop through and say, based on this global list of our PIDs, keep on looping through until you get up to the number that we want, and keep on spawning workers each time. And then once you hit the number that you're looking for, then you stop making new ones. So then there's this really simple main function, which is just parsing the command line arguments, looking for an optional parameter called processes that will indicate how many processes you want to run on this one. So there's a pretty serious bug here. Does anybody see what it is? It's kind of subtle.
Int instead of string for default.
Well, this is an integer. Default equals 1. That 1 is an integer, right? So let's try running it. It works, right? We had a default.
What happens when you pass in an argument there?
Yeah, that's the next question, right? So the default was 1, right? So what happens if we say we want to run with 4 processes? Oops, I just fork bombed the entire computer, and all the other users are now unable to access their terminals. And this happened to me when I was at work, and we had like a multi-user system, and about 10 other people were using it, and because of this bug, they all were unable to do work until I figured out that I was screwing it up and aborted the program. But take a look at what happened here. What happened is, in this add option, by default, command line options are strings. Okay? So when we don't specify, you can actually add an optional parameter to the add option command, and that will tell it, no, we want this to be interpreted as an integer, but I forgot that option. And so therefore, when I get to this line here, when I say options.processes, this is a string, right? Now what happens when we pass a string to the spawn workers function? Well, it's comparing the length of the workers, which is an integer, to a string. Now, does anybody know what Python does in that case?
It's always less.
It's always less, yeah. So the reason why it's always less is because, at least this is Python 2 that we're running right now, but Python 3 kind of fixed this. But in Python 2, it says, well, I don't know how to compare these types. They're not both numerical. What I'm going to do is I'm just going to look at the alphabetization of the type name. Okay? So this is an integer, which is an I, and then n is a string, which is an s. It says I is less than s in the alphabet, therefore true. and when that was the cause of my bug, I got really mad at Python. I said, this is a little unreasonable. You know, that's not the way that you compare things. So that kind of motivated, that and along with a lot of other issues, kind of motivated me to want to try to do something about this. And I started working on a project that's like basically a static type analysis tool. And so, for example, if we try to do something like this, let's just do a simple example. We say like a is equal to 1 plus 1. Let's see what happens. See, this is kind of like a lint tool. And so it ends up interpreting it as a number kind of arbitrarily, but it also tells you there's a type error, and it's saying that like we're expecting a number, but we actually got a string there. And so because it could have been a number or a string, it's kind of arbitrary whether it says like, you know, number versus string or string versus number. But you know, that's just something like an improvement I could make in like the messaging. But the idea here is that it's actually going to figure out what's wrong. And so there's a little bit more interesting cases here where if we say let's make a function and let's return a times b. So in this case, it actually is inferring the types of the parameters of the function based on the contents of the function. So it says if we're going to be multiplying two parameters, the only things that you can multiply in Python are numbers and strings. So it's basically going to say that A is a number. Wait, that's probably a bug because it's supposed to be both of them are unions, numbers and strings. And then it's returning a union of number of string. And union just means it could be either one, right? Oh, it's because we have a type error still. Yeah, let me get rid of that. Okay, there, that's better. So you can see how A and B are both union numbers of strings, and then the result is a union number of string. That's because Python allows you to multiply a string by a number. Do something like, say, let's add 1 to that expression. Now it says, well, you can't add 1 to a string, so therefore the parameters must be numbers. And so now it's inferred the types of this thing. But let's make it a little more tricky. Let's say if A is greater than 1, else none. Now look what happens. This is actually from Haskell. So Haskell is my other favorite language. And in Haskell, they have a concept called a maybe type. And so maybe means it might have this value, or it might be none. Or in Haskell, they use different terminology, but like they use the term maybe type in Haskell. And now, what this is really interesting is that a lot of times what happens, the bugs that you get are like a function sometimes returns none, usually returns a number maybe, but every once in a while returns none. And then you go and you do something with that. And you say, well, let's say C is equal to f of 1, 1. C is equal to f of 1, 1. So the result of that means now the value of C is a maybe type. Well, if we say, what if D is equal to C plus 1? Type error. You can't add a maybe number to a number. You have to actually make sure first that it actually is a number. So here's what we can do. We can say if C is not none, then E is equal to C plus 1. Else E is, let's just say E is none. This is so now we don't get an error on E. Right? We still have the error for line 7 where C was coming from. So this line is still an error. But this one is not. Even though it's the same expression, it's actually inside of a scope where we can infer that that number has been unpacked, you could say, as guaranteed that it's no longer none, and therefore it's valid. But now the crazy thing is that you can actually have more complicated expressions here. So if C is not none, and let's say like random is greater than 0.5, something that can't statically evaluate. So not a fun. I have to say import from random, import random. So we can see in this case, it's still inferred. There's no type error there. It's still inferred that that's okay. Let me just delete this one so it's more clear. So there's no type error at all, right? in this case, because if this whole statement is true, then both of them must be true. But if we had an or here instead, then you can't logically infer that it's not none anymore. So you still get a type error. So it's actually kind of smart enough to figure out, can you logically derive that this thing is guaranteed to be none at that point in the code? And if you can, then the type gets unpacked automatically. So basically, there's other features to it, but that's the general idea. The idea is that we would be able to, before ever even running our code, find a large class of potential errors, and in cases of our code that we might not ever actually even execute in our testing. Sometimes you might do all your unit tests and everything's fine, and you ship it to your customer, and they do something that you didn't have in your unit test, and all of a sudden it blows up. It could be in a very critical application, that would be really bad. So this kind of thing could somewhat help with that, those kind of problems. And so I, right now, am kind of unsure of how I want to proceed with this project. It's not finished yet. It's a lot of work. And if anybody has any feedback on it or wants to talk about it, definitely let me know, because I think this is really fun stuff. But I'm not really sure how interested people are in it. So yeah, just let me know if you wanted to talk about it at all. Thank you.
Can you speak just briefly on what it's doing? That's pretty awesome.
What it's doing?
Yeah, how does it work? What's the basic technique that you're using to get inside the if
Well, so I guess the basic technique is that built into Python there's a module called AST, which is abstract syntax tree, and they have like a class that's called a visitor, and so basically it just lets you kind of walk through the syntax tree that's automatically parsed by Python, so you don't have to even write that code at all. So if you're familiar, there's actually a project similar called MyPy, which is doing something kind of similar for Python 3, but that requires actually annotations on your function definition. So like I don't really like that because you have to actually kind of like change your code quite a bit, and also not enough people are using Python 3 yet.
For the if statement, for instance, if you have to evaluate the if statement in the context to figure out, or are you computing the types pretty statically?
Well, this is all static. There's no actual running of Python code. It's a Python program, but like the.
I mean, do you like parse it, AST, and say, "Oh, try this type and see if it works," or try this type and see if it works, or you're doing pure static analysis?
It's pure static analysis. So what happens is like if you have an if statement, it actually has to descend down both branches every time, and then it has to. I call it like unifying the types. So if you have on one branch, it's something that's a none, and on the other branch you have an integer. Then it looks at that and it says, okay, the result of this, if we can't statically analyze the conditional, the test, then we have to consider that to be a maybe type.
Oh, okay.
And if we can statically analyze it, then we just choose the appropriate one. Yeah, so it has to step through everything. And the other tricky part is one of the trickiest parts is trying to infer all of the constraints on the function parameter names, because you actually have to like kind of recursively descend through the whole parse tree, passing in your whatever type you expect to be found at each point in the expression, and then use that information to try to figure out like what the types of all the symbol names are in that scope. Yeah, it's pretty tricky.
So does this also work with like general classes, or just with the basic types?
Oh, with classes, you said? Yeah, it has support for classes. Although there's certain it's not fully input, like it doesn't support class methods yet, and there's a lot of shortcuts that were taken. So for example, like it won't let the thing is you can still do anything you want to do, but the thing is there might be spurious warnings, or there might be warnings that it misses, and it doesn't of course it's kind of like a lint tool, so it doesn't hinder you in any way except for the fact that it might waste your time if you interpret it wrong.
Instead of static, maybe it would be better if at runtime it wants this. Maybe runtime may be more easier.
The whole point is for it to be static. We already have runtime analysis in the CPython. Because when you run your program in CPython, you run through it in a certain code path, and then if it crashes, it crashes. The problem is there's many code paths, and you are not going to go through all of them.
That's the problem here also. Like if you have a really large program, if you want to traverse all the paths, how much time? Like for a really big program, it will be a lot of time.
It's linear in the number of lines of code you have. Whereas if you're executing, that's not really the case anymore, because you can actually like branch. You can go do like recursive functions and things like that. Whereas like in this case, a recursive function, it kind of like it kind of cheats, and it just says like, well, I don't know what the return type is of the second level recursive call, and it just tries to do its best guess that it can. Whereas like if you're actually executing, when you're executing, you only go down one code path at a time. So if you have a lot of if statements and for loops and recursive calls, that should be completely different. And the other thing is that when you're executing, you have side effects. And like
when I said runtime, I really did not mean to run through all the paths, but just the current instance. So if you ran the program, right, then you had a different loop, you just can't catch that instance, not run through all the paths.
Okay, I'm not sure if I follow. Okay.
So we have 3 more talks. It's not really getting much cooler here, so let's get out of here fast.
Alright,
I'll go eat something.
try my best.
Alright.
Props to the live coding, by the way. I'm not going to do that.
Yeah.
So, quick demographic question, because this is aimed at beginner to intermediate. How many people look at this first part and think that they kind of basically already know what's going to happen? Paul, you can be honest. I might know. Maybe. I mean, okay. All right. So this is Monty Python. All right. So I'd like everyone to look at this code, and can everyone see it? And
Yeah.
see if you can guess what the output's going to be. So, show of hands, A. Show of hands, B. Show of hands, C. Not many brave people here. So, the 2 people who rose their hands were right. Now, so the question is, what happened? Because if you were naive to this bit of code, that might be surprising. That was the output. So what happens here is first, this list gets created with a 0 integer in it. That gets loaded into memory, and that gets bound to the name myList. Now it's getting passed to this function, and this name now is local in scope. This original object is still living in memory. This new object is now created and getting assigned to myList in the local scope. That because the scope is local, it doesn't affect the original myList name or the original object. So really nothing happens to the myList in the main scope. And then, but append is different. Now the myList object or name is passed, and the object is referenced here, and a 1 is appended to it. And so that's why you get a 0 and a 1. All right, so based on that output, here's another one for you. This one is slightly simpler, same concept. All right, show of hands A, show of hands B, show of hands C. And we have wisdom of the crowds here, C is right. And something similar is happening here. Object is created. Now, now list B, the name is created, and it's bound to the same exact object as list A. And nothing new in memory is being created at this line of code. They're just 2 names that are now pointing to the same object. So now when you append a 1 to list B, it also affects A. These were kind of problems that I hit embarrassingly late in the Python game, and that's why I wanted to share them with you guys. instance and says returning is for suckers. Don't code like Homer. Although you might have a good reason to. All right. So this is a somewhat contrived speed test where it's a sorting. They're theoretical sorting algorithms. So you have 1 and 2. They're both calling the same thing here, but that's not important. You create your test list, and then you time it running through the first method and then through the second method, and then you want to see what the output is. Scroll down a little bit. Scroll up a little bit. All right. So the first time it runs, it takes 0.33 seconds, I believe. I forgot what unit that's in. And then 0.05. So there's a speed up of 84%, which is ridiculous, obviously, because these are the same exact sort methods. So what's happening is that the test list is created, it's sorted by the first method, and it's still sorted when the second method runs it. So it's a much easier task for the sorting method to accomplish, and it happens a lot faster. So, if you're looking at this naively, you might think, wow, the second algorithm is way faster. So here's a workaround that you might do. And basically all you do is you create the first data structure, and then you use the copy library to create a copy of it. So functionally it's the same, but it lives in a different piece of memory. So you're not running the same, you're not running algorithms on the same piece of memory twice. Here's another nuance here. You've got Bill and Hillary. They're immutable because we put them into a tuple. And guess what happens? Bill, Hillary, and Monica. So this is basically because the tuple is immutable, but it references mutable lists. And so when the list gets updated, so does the tuple. All right, so, here we go. Is it call by reference or call by value? Yes, no, neither, both. This is definitely a point of contention on the interwebs. I don't know. I have my own, bias, and that's because I learned about call by reference and call by value with C, and that was basically call by value meant, something very specific, and it seems that that this is very fluid, just like language often is. Oh yeah. This also relates to garbage collection because I guess every time an object is bound to a name, the number of references to the object are incremented. Deleted object, the reference is decremented. And so when a counter reaches 0, the object can actually be removed from memory. And here's a simple example of that happening. Okay, any questions?
He's going to speak. Speak trees. Who was? Why was? My generation was. Come over here.
I know it's getting late, so I'll give you a little bit of a break from talking about Python here. Hopefully I'll fly through this real quick. Now, what am I going to click here?
By the way, the IPython notebook I just ran is going to be on the presentations GitHub repository, so feel free to check it out if you want the reference.
Almost up there. Yeah, whoa. So
That's how hot it is.
bad to worse. That'll work.
Made for beta operating systems.
I don't know what's with the color though. You want? I mean that's not the color of the slide. Yeah. What did I click? Just the arrows?
Yeah, yep.
That works. Okay. All right, everybody. Be prepared to be amazed. Alright. Real quick, some of you guys might have seen me. I'm kind of a lurker here. I've been to a few of the meetups. I lurk in your IRC channel. I'm Eric Van Johnson. I'm a PHP developer and architect and one of the organizers of SDPHP. You can pretty much find me anywhere on the internet as Shokum, including your own IRC channel, which half you guys probably don't even know you have. So Trey asked me to come out here and talk to you guys real fast. I mean, let's be realistic. If you're in the industry long enough, you've probably touched some PHP code at some point in your life. Some of you still might enjoy it. I know I particularly do. I actually make a living by it, and I have a lot of friends who make a living off of it. There's been some huge changes in the PHP environment, and the PHP world in general in the last couple of years. One of the biggest changes that we've had here in San Diego is our community. The San Diego PHP community had gone dormant for quite a few years. About 2 years ago, my partner and I, my buddy and I started up the San Diego PHP user group. He actually started. I was like one of the first members and helped him get along. I was a member of the previous PHP user group here in San Diego. Anyways, that's one of the biggest changes here for PHP in the San Diego area. We actually have a community now. You can find us at sdphp.org. Of course, we're on Meetup like everybody else. Twitter account, which we don't really tweet that much. IRC, which is big for us. We have a pretty active IRC channel. Trey is in there. A few other people will pop in there. We typically will have over a dozen people in there, and occasionally we'll. So we actually hold 2 general talk meetups. We have one downtown. We have one up in North County, up in Carlsbad. We get good turnouts for both. We rarely overlap talks. Occasionally a talk from downtown will get requested up in North County. And so, for example, we had our most recent one downtown was building APIs. So we're going to be doing that one up in North County here in a couple months. We also have 2 study groups, again, down in Mission Valley and up in Carlsbad. So there's a lot of activity, and of course we do conferences and stuff like that. So that's community. For PHP itself, as of today, 5.6 is released as stable, so that's kind of cool. One of the interesting side notes here is that the next major release of PHP is going to be PHP 7. We're not skipping PHP 6. That was kind of one of the conversations. PHP 6, little known to a lot of people, was actually released. It kind of flopped. I'm not even sure if it was ever released as stable. It just kind of got out there. When they decided to pull back on PHP 6 and refactor it and make it right, we've been on PHP 5.x for a number of years now, so this didn't happen in a couple of months. But when they did make the decision to pull that back on PHP 6, the problem was a lot of overzealous artists, authors, and publicists had already started releasing books on PHP 6. So when everything got reworked, there was a discussion and a public vote, on what the next version of major release should be called, PHP 7.1, because the biggest kind of factor was the fact that there were all this wrong material out there around PHP 6. But that's all in the future. We still have good stuff here. If you haven't worked with PHP since PHP 4, then you haven't worked with PHP. If you haven't worked with PHP since PHP before PHP 5.3, you really haven't worked with PHP. PHP 5.3 is when a lot of cool new features, well, cool new to us, but features that have been around in a lot of languages for a long time. So as of 5.6, very commonplace now are namespace, using namespaces. we love namespaces. I mean, it's used all the time now. We understand other languages have had it. We got it, I think that was either 5.3 or 5.4. I think it was 5.3, maybe 5.2. We have traits, which is kind of our workaround for multiple inheritance. I actually don't have a good use case for traits. I don't, because I use namespace so much, I haven't had a real need for traits, but I know that was one of the things that, especially people working in other scripting languages, were big on, was this multiple inheritance. And so traits allows us to do that. We have lambdas, which are like anonymous functions. Does Python have lambdas?
Yes.
Yeah, okay. So we have lambdas now. We have closures, which are lambdas that can have values passed to them. Again, these are a lot of features that many other scripting languages have. PHP not only do we have it now, but it's become a standard on leveraging it and utilizing it, which has brought us around to making a lot better code. So PHP movements. So besides just the new features, there's been a lot of just movements in general around the PHP community. And these are, again, pretty much community driven. Composer has been a game changer for us. For PHP, previously, we tried to do package dependency through, I think, pair, which was a system-wide implementation, very difficult to work with, very difficult to package and deploy on multiple systems. Composer allows us to have package dependency management on an application-by-application implementation. You can actually have multiple composers within one application. I'm not sure why you would. The thing about Composer is it handles all your dependencies, updating of those dependencies, version control of those dependencies. So you can say, hey, the Guzzle package, give me whatever the current release is, whatever development release is. But when you go to production, you can say, lock this Guzzle into 1 point whatever. So that's been fantastic for us. We love that. Again, some community-driven standards. We now have the FIG, which is the Framework Interoperability Group. These are really a bunch of people who have been big in the PHP community, and they finally did something that was missing in our community for a long time. They all got together and started pounding out these standards and saying, okay, this is how we need to make sure our libraries are built, make sure that they work from one framework to another framework. So now you'll see like the Symfony packages get shared a lot in a lot of other frameworks because of this. Kind of along the same lines are the PSRs, the PHP standard recommendations. This is what starts to define how auto loading happens, coding standards. I forget what all is involved, but these are a lot of standards that the community. I mean, we're not enforcing them. They're just being documented and strongly encouraged to follow. Again, we've been missing that for years. I might be done here. Oh, and then our frameworks now with the release of namespaces, Composer, our landscape of frameworks has changed. There's becoming less and less of a need to do your own coding. Getting kick-started with a framework is so easy now. We have enterprise-ready, battle-tested frameworks like Zen, Symfony, Yi are all huge frameworks that are out in the enterprise now. Laravel is a big framework in the community right now. And one thing about Laravel is that it's pretty much taking advantage of just about all the cool, bells and whistles that are released in PHP. And of course we got some of the old standards. I'm personally a long-time PHP guy. And I think that might be it, and that's it. How's that? No? Perfect. Way to go, guys.
Hang on now, okay? We're getting there.
This is a long time. I want to go home now.
Keep drinking.
What's he drinking?
It's hot in here.
Last one. I know what you all think. O'Brien, beer, cool fresh beer. Too bad I'm going to tell you about soup. Beautiful soup. And 5 minutes, right? How many minutes I have got if we deduct all the overtime from the other guys? I'm probably negative now. I'm going to beat the record. Negative. I actually did that last month. I didn't show up. Okay, so beautiful soup. Well, one way to make this short is I'm not going to tell you much about beautiful soup because I have two things to admit. I don't know much about it. I'm not an expert. I just learned about it 3 weeks ago. And the other thing is the main motivation of my talk here is a shameless plug for a tutorial I made. I wanted to learn a couple of people, especially Russia from the Better Sounds came and she wanted to do some web scraping. So we did that together. We found a tutorial. The tutorial was not working because it was old. The website it was scraping had changed. So well, we did our own tutorial, and now it's published on GitHub. So what I really like to get out of this talk is that it's available on GitHub if you ever need a tutorial. It's really step by step, and I think it illustrates what you can do. I have no time to go through tonight. We need at least half an hour. So I'm going to tell you what is beautiful soup and some of my observations. And I really like people. I know that people know much more about it than me, so I like them to comment and ideally talk more than I do. But let's get going. Oh, that's not it. Sorry. I want to see my introduction. So that's the GitHub. There is this talk, and then there is an IPython notebook with the whole tutorial. And I just removed the instruction about how to install IPython because that was in the IPython, a bad idea. But anyway, so okay, so what is it? It's a Python library to do web scraping, getting data out of websites in an easy way and build application using that tool. Why would you use it? Well, I'm sure you have come across websites that are badly designed where you have to go through lots of links and finally you find your true font. Say, okay, I'm going to bookmark it. Too bad because next time you want to do something else, but you will bookmark it to search again. So you can use that to make it easier to find data like that in badly designed websites. Also, you can automate. If there's something you do repeatedly, you can automate with that tool so that the computer does it for you. One thing, it's not a miraculous tool. There are actually better tools out there that I haven't tried, but I've heard from it. What it doesn't do is it's not going to find things that you don't know already. So you have to know how to go and find your information yourself manually, and then you automate it. It's not going to discover things that you don't already know, and it's not going to do very clever things. So how do you use it? It's basically a 4-step process. There's a little bit of work you do and a little bit of work that beautiful soup does. Preparation. Your role is to find a URL and build it. Beautiful soup doesn't help you there. I have a tool that helps you there. You're on your own. You may use Python. You may have to do a URL with a question mark and all parameters to find the page where you're going to find your information. That's your role. Now, when you have that, you can ask Beautiful Soup to have a look at it and get all the data and make a model. That's what Beautiful Soup does. It does 2 things. First thing, preparation. It does a model of everything on that page. And the second thing that Beautiful Soup does is answer queries. That's what I'm going to give you an example. So you're going to ask, okay, find me all the links on the page, all the links that have a class of this. You have to know a little bit of PHP and CSS because your question, it helps if you are familiar with JavaScript and jQuery especially because it's the same logic. And okay, other example, last example, find me all the table headings that's got bold text and then give me that text. So that's beautiful job. Now your job is to exploit that. It's going from Beautiful, you're going to have a list of information extracted from that page, and that's your own. You need to do whatever you want. Pretty print, make a CSV, put it in database, whatever. And you may have to do repeatedly things. So you may have to build a bit of code to do that work on top of Beautiful Soup. I like to have lots of questions, especially comparison, because I know there are other tools. And if people have experience doing that with other tools, especially JavaScript, I'd be interested to know. But let's have a look at the little bit of code. I always hear about the 10,000 feet view. Come on, metric system. So let's have a 3,048 meter view code. These are actually extracted from the tutorial. And I picked them to illustrate the general idea that I just described. The first two here are about the preparation work. So you see, you may have to deal with a very deep and weird and complicated URL with lots of parameters. Let's jump to build it. Okay? Too bad. So you build that, but then you have Beautiful Soup that helps you, and this is the first part of Beautiful Soup. You find the URL. You may use a standard Python library here to prepare to get HTML code, and then you give it to Beautiful Soup. And this is the code that's going to build your model with everything. I'll talk about that later. You have a parameter here. You can choose different parser. I don't want to go into detail about that. I'll come back to that. And then the last thing, that's an illustration of what you do. When you have your soup, here's my soup. I do things with it like that. I say, okay, I want all the li. Very often, if you have several interesting things, there are bullet points that li. So you can say, I want all the li that have class this. And this is going to pre-select a list of different things. So it's focusing on what's interesting. It's not yet your final result. Your final result is here. With each of them, this works very well with Python. So I have what do you call that? List comparison. So for each item in my list, I'm going to take all the A's, the links, and I'm going to take the href. I want the links, the URL links, and I return, I have my list. Now, Beautiful helps you building the object, that's your call, and then you have a list that's up to you to do whatever you wanted to do with it. All right. It's very powerful for several reasons. It works well with Python, you know, this kind of syntax, this compression, there's a few syntax. When you got that, you can build on top of that your own application. The second point, I don't really understand, but you don't have to worry about this. So let's not worry. It does all the Unicode and converting to between different characters. So you don't have to worry about it. And here I come back to the parameters. When you use that, I talk to different people who say, oh, it was not working for me, it was hard to install. Well, you need to use a parser that doesn't come with Beautiful Soup. That's a program that's able to interpret HTML code. And there is one which is included in Python, but it's a little bit buggy. A lot of tutorials I saw use that. It's very fast, but hard to install. It's using C libraries. I use this one. It's just Python. You need to install it with PyPy. It's supposedly slow, but it was fast enough for me. But when it comes, remember that you have a choice and you can compromise between speed and ease. All right. I also heard that Beautiful Soup is good to go, but when you are a big company in fractional services and you do that day in, day out, you need something a bit more powerful. So I don't know much about that. I'll be happy if someone can talk about more. But what I understand is there is a tool called Scrapey, which is like the Django of web scraping. It has everything. It makes you do things correctly and automatically. So your thoughts are welcome. If you want to compare, maybe Beautiful Soup is just a library doing, maybe just like Jinja, that's just templating as opposed to automate and the things upstream, building your URL, the thing downstream, automatically will do the same thing every day. Or search, I said you have to provide the URL. I think the other one helps you find interesting URLs and do clever things. Here, where I wanted to land. Okay, first of all, thank you very much, Trek. You were a bit late. This is excellent, but I saw it too late. So there is on Trek's blog, there is a very good example and useful one. I'm starting using it to do web scraping to find audiobooks. So have a look. Now this is the one I built with Russia and others. Melanie is there, you have a look. Chris. It's based on this, so this is all and not working. This is recent and working. I prefer if it was based on San Diego. It's about exploiting a website that gives you the best of restaurants in Chicago. So have a look. That was my goal. So I'm here, and thank you everybody. Comments?
We play with Scrapey. It's quite handy. The main problem that Scrapey solves is with Beautiful Soup, you're downloading stuff, and you have to handle all the horror HTTP error code yourself. Scrapey pretty much is a service that handles some of that jungle, but all of the parsing of the document and everything you can still use Beautiful Soup to do. So they play hand in hand.
Who else is doing great scraping? Okay. No? I think you do, no? You do?
One thing I've noticed with Beautiful Soup is it doesn't handle inline JavaScript very well, and it likes to remove the script tags and leave you all the JavaScript code, and it's really nice if you can find a way to remove that beforehand, so that it doesn't have to deal with it. But other than that, it's worked really well for what I've used it for.
Now, I was puzzled when I discovered that I thought, oh, it really looks like jQuery, and then I wanted to type jQuery sentence. It was not quite that. Are there similar tools in JavaScript?
If you're using like XPath selectors, some of those selects go away, not all of them. I don't know what support Beautiful Soup has for XPath.
Also, if you ever find a site that has inline styling, or not inline, but like a styling block, just like the JavaScript, it doesn't handle that very well. Although if you're scraping a website with that, you may want to rethink the choices of your scraping for more, standards and compliant websites.
All right, so now we're gonna put the chairs away, leave the room the way we found it. If anyone wants to borrow either of these books until next month, come up here and feel free to look at them. And then we'll go to O'Brien's across the street to get a soup.